I finished the oh, is it all right? Welcome back. Right, cut that. Hello and warm welcome back. Today on the bench once again is the output transformer that I wound for the new amplifier. As you can see, I've finished terminating the various windings. Not impressed with that in some places. It could have been a lot better, so that's a note for next time. What I've just used M 2.5 or 2.5, yeah, metric 2.5 millimeter screws, bolts, because I would rather have used turret tags, but they are quite expensive and I haven't got any, so they'll do it a pinch. Yeah, like I say, I'm not impressed with the finish on that. So anyway, at the moment, as you can see, I've got my AirMech type 251 ionization mega sort of type tester. Basically it puts a very high voltage between whatever you're testing and reads off the resistance. So I've got it set to 1000 volts at the moment, and if you look at the meter, that would be a bad reading if it went over to the right hand side, full scale deflection. If it stays over here, that's good. So I have it set on 100 microamps at the moment. And as you can see, we have a reading of over 10. Well, it's infinity. Just turn that down. So if we look at our scale here, 1000 volts at 100 microamps times whatever result that we have on our meter by 10. So 10 times 10 is 1000 meg. Click it onto the next setting. As you see, the meter starts to go over full scale, and that's reading at 5. So that is 5. Hold on, where are we? 0.1. So 5 times 5 times 100, so that's 500 meg ohms. Sorry, I'm just not really with it there. I don't know if there's any point really setting it to 10,000 volts. We'll try it. So that's not a bad reading. 10,000 volts, so you times the result by 100. So that's brilliant. That is something that I was quite worried about, the primary, secondary. Yeah, I was a bit worried about that, but yeah, that's tested fine. So next we just got to bung in all the laminations. Well, here's the output transformer, ready to do some frequency testing and some ratio testing. I did some yesterday, and the results that I got weren't what I was supposed to get. So an output transformer is a step down transformer. So on the primary side we have a high voltage with a low current, and then we want to drive a speaker, we need a low voltage high current for the speaker. So you've got something like, let's say 2000 turns on the primary and 100 turns on the secondary, and that gives you a ratio. That gives you your turns ratio, and then you can also do it a voltage ratio. So let's have a look at the voltage. So I've got 2 volts coming out of my signal generator at 1 kilohertz, and that's what we've got going in. It's dropping a bit obviously because there's, you know, the output transformer is a load. So we've got 1.958 going in. What have we got coming out? Just had to rejig the test setup there. So what did we have? We had 1.958 or something like that. Let's just call it 1.9, and we've got 0.1 coming out. So we do the old maths. Calculator on. 1.9 divided by 0.1 equals 19. We get that and we square it. 19 times 19, because that's the turns or the voltage ratio, volts ratio 361. Right, then we times that by 8 if we're going to have an 8 ohm load. So I make that 2,888, or about 3k, which is less than our 4k which we wanted. Oh dear, how can that be? Right, cancel. So was where I think it was 22.36, so we had 2,200 turns on there, divided by, this is the ratio we should have, not 19, we should have 22.36 equals, so that gives us the secondary turns that we wanted on 98. The secondary was divided into 3, so we divide that by, oh shit, divide by 3, 32. So there should have been 32 turns on each secondary layer. However, I think I put on more than that in my enthusiasm. So let's say I put on 36, let's just say. Cancel. What's that? 36 times by 3 equals 108. Cancel. So we got 2,200 divided by 108 equals 20, which isn't far off our 19 ratio, is it? So that's the reason why that's off. Will it matter? I don't know. Could we do anything about it? Yes, we could. I've got 3 secondaries on there. I could just use the sort of, basically we've got, right, hold on, let me draw you a picture. Let's draw a picture. Right, where are we? So this is the bobbin. Okie doke, hope you can see that. I can't see bugger all. There's a bobbin. So we've got primary here and a secondary and another primary, another secondary, primary. I'm going to need a bigger bobbin, ain't we? Primary, secondary, primary. So all the primaries are connected in series. Yeah. Anode, where's the centre tap? Here, innit? Centre tap. We could just connect this secondary S to this one down here and get a lower voltage ratio out. So basically each secondary on their own is kicking out 0.36 millivolts. I don't know whether this is right. I've got a sneaking suspicion it's wrong because some of the maths is a bit weird on output transformers. So what are we getting? 1.9 divided by 2 times 0.036, 26. But that's not our ratio, is it? So what would that give us? 26.38. That's not enough turns. What was that? 28.36. Oh, for fuck's sake, I've forgotten. $26.38. Cancel. 26.38. 26.38. 26.38. 26.38 squared. Oh shite. 26.38 equals 695 times by 8. That'll give us a primary of 5.5K5. So we're screwed whichever way we're doing it. So the only thing I can think of doing is just to try it. 3K. It might work. It might work. Might work. I don't know. So I'm going to knock up a prototype and see. But you can sort of see by putting on the secondary, by just winding on 4 extra turns per layer, knocks your impedance ratio out a lot. Yeah. Anyway, let's have a look at the frequency response. Let's cheer ourselves up. Right, there we go. Right, there we go. Managed to get it to what's it. So we're looking at the output. That's 100 hertz. Knock it down to 20 hertz. That's looking alright at 20 hertz, isn't it? Yeah, that's a very good low frequency response. So our waveform fills the screen. Let's bang it back to 1 kilohertz. See, fits most of the screen. I won't worry about that rounding at the top there. I think that's just a artifact of the, where do you call it, of the scope plugin. Right, so it was good at low frequency. How high will it go without degrading? Frequency 10 kilohertz. Still alright, we've still got our amplitude, it's not rolling off much. Frequency, oh fuck, frequency 20 kilohertz. Oh, I've already done. Frequency 30 kilohertz. Okay, it starts to roll off at about 30, but it's still not 3 dB. No, it's still not 3 dB down, so at 40 kilohertz, so it's not too bad in terms of frequency response. It's just a shame that our impedance ratio is out. Short of rewinding it, not much I can do. So I'm going to go and test it first, see whether I can get away with it, because I really do not want to have to rewind that all over again. It's a dear do as well, not well in time, and copper. Copper's about, Jesus, about 30 quid for the primary. Yeah, but off, yeah, a bit less than that, maybe 40 quid for the copper, and obviously the laminations and all that. But Ian gave me those, so save there. But still, you know. Anyway, let's go and build an amplifier or prototype it. Let's get some valves out. This jackdaw has been driving me mad for days. All it keeps doing is going check up, back up. all day, every day. There's usually a family of jackdaws come round early on in the year. Mum, dad, and usually about 2 or 3 youngsters. So whether that's a youngster or whether that's the mother calling the youngsters, I don't know. And I can't see them. They're always out of sight. They're very canny beasts, very canny birds. They're very wary of humans. Anyway, yeah, it's driving me fucking nuts. Yeah, appropriate or nothing. Well, after a few days of work, we've got a chassis-ish. It's not up to my usual standard. I've knocked it together quick. I didn't want to spend bloody weeks on it like I usually do. So that's the back. That's not it. That's the back. Got a bit of plate there, which fits in there-ish. Fits in there-ish. That's where the speaker terminals, IEC main socket, etc. will go. And then we've got a couple of cutouts inside for the pots. So I'm using Bourne's pots again. This is just an old one. They will go in there. That's the front, a bit marked up, but I've got to obviously sand that and thing. It's just some old wooden drawers that I had, bits and bobs. And then we've got our cutouts for our valves. 2C34s, 12BX7, 6H8C, 2C22, I think. Yeah, or Det 19, and obviously the OPTs will go there, and I'm just waiting for the battery to charge. Toroid will go in there, sorry, go at the front, so that will basically got your OPTs over here. So that will balance the weight out. Not ideal, but I've built a shield, as it were, to go round there, and that gives us plenty of room for everything else. It is a bit deep, as you can see, but that's because toroid is deep, and yeah, so not my most brilliant of job, but there we go. But I'm going to use some veneer, and that will go on the sides to tidy that up a bit, and then we can start on actually building the amp. As you can see, the joints are really crap. The chassis is outside clamped up with the veneer on it, and then inside I am trying to work out the layout. I've got obviously the placement of the valves. I sort of did some preliminary sort of layout. This is just a rough plan of what the crack is. Right, that's right. Yep, I think. No, it isn't right. That is one half of the 6. That is one of the 2C34s, 12BX7, and the face split of the 6H8C. The 12BH7, the 12BX7 has got to have a couple of sort of potentiometers there to set the grid voltage, because this is going to be fed off a constant current source sink, same as the phase splitter, but we need these pots there to set the grids, which therefore sets the cathode voltage, which in turn sets because the cathodes connect directly to the output valves, so you have to adjust the grid of this valve here so that this valve here is biased correctly. It'll all become a lot clearer, hopefully, when we get further in. So I've got these lovely Colvin pots. That one's been used, never mind. I could use like a tiny little preset sort of thing, but I'm trying to sort of up my game and trying to make, you know, everything as tasty as possible, because the previous amplifiers, well, they're functional and were reasonably neat. Yeah, I think you can always do better. So for inspiration, I've been taking inspiration from the DIY audio photo gallery pages. I quite like some of the work on there. It gives you some great ideas. And also the original inspiration of this amp and the one before it was a guy called Torben, or Tricomp. He's published an article on his build of this amplifier, albeit he only uses one valve, 1 2 3 3 4. So yeah, I want to try and make it as good as possible. Regarding the where do you call it, the toroid, I keep getting wasps in here. I wish they'd feck off, because, pardon my French, I'll need to moan about. Look, the divvy bastards. They keep looking in that hole over there. That's the keyhole for the door. And then they keep coming in. You know what wasps are like? They like fly around your bleeding ears, and just, it's not very conducive to like getting stuff done. Bees, bumblebees, I'm fine with them. Wasps. Sorry, I digress. So the toroid will go there. Made the shield. That took me a hell of a long time. Prevaricating and messing about and bending it and plonking it and knocking it. So that's the crack there. Our wires will go through there. I made a screw up on the output transformers. These output transformers are bloody ridiculous. They are a bit big for the job really, but never mind. So I wanted to try and keep this amplifier compact and small and not have it sprawling all over the place. It's already big as it is. However, I screwed up. See the problem? Hold on, let's point you a different direction. That's not the correct alignment, but you understand what I'm saying. Look, so, and that is right at the end of, you know, right at the back. However, I have a cunning plan. If I set that back a bit there and then make a bracket at the back so that it doesn't screw into the top of this plate, it screws into the wood behind it, sort of thing. Again, you'll have to wait till I sort that out. And then therefore they don't really give, they haven't got a key. Come on, you fuckers. There. So now that just clears that, and then obviously we've sort of got a valve there, other valves there. I did experiment with different layouts, trying to sort of mess about with the valves, but I wanted the layout to be functional more than anything. Aesthetics, yeah, it's all well and good. On the last stamp, like, I sort of offset the valves so that you could see all the valves, but to be honest, I listen to an amp more than I look at it. So said I gave some, come on, focus. As I said, I did some preliminary, God, my voice today, layout, so that the heater wiring from each valve comes out this side. So on this valve here it's 2 and 7, 2 and 7, and I think that one, hold on, let me see, heater 7, okay, oh no, right, 1 and 7, right, no, on this one it's 7 and 8, and on this one it's 7 and 8, and on this one it's 2 and 7, I think, something like that. Anyway, the heater wiring will be sort of out the way, all twisted and lovely, and then, like I say, it's just a matter of, you know, connecting all the components up. There's not a lot to it really. This is the beauty of valve amplifiers, in that you don't need a load of components to make the buggers work. So we just got a couple of resistors up here on the anodes, one resistor on the cathode. This one is a little bit more complex because we've got to have our balancing pots, as it were. This one just a constant current source and a couple of resistors on the anodes, grid resistors, and like the cathodes are just a constant current source. And then this one we like sport for choice because all of these pins apart from one, oh no, sorry, 3 are not connected. All this valve has connected on the base, heaters and the cathode. That's it, because the grid and the anode are on top caps. This is just an old knackered one. So it's shaping up. I think this probably will be getting, oh no, one other thing, I'm prevaricating about using a choke. I've got this big core here that would do. Really though, this choke here, 10 Henry's, 180 milliamps, might do, but I'm sort of going a bit out to lunch on this amplifier with the iron, so yeah, but we've got room for that. And then regarding, what do you call it, filter capacitors wise, I've still got a few of these big 820 microfarad bodies. On their own they would probably do the job, so I've yet to have a think about that one. Right, I think we'll cut it there, and I will see you in the next one, and then hopefully it will start to really make a lot more sense and all the rest of it. Thanks very much for watching. Take care of yourselves. Ta-da for now.